Welcome back to The Deep Dive, the show where we take the source material you need to master and, well, we slice right through the abstraction to get you to the core insights fast.
And today we are diving into a really high-stakes conversation. It's one that challenges the entire foundation of how, the legal, policy, and tech worlds are trying to regulate artificial intelligence.
It all starts with this dominant narrative, doesn't it? The one you hear everywhere?
It does. Let's call it the accountability orthodoxy. I mean, if you follow the regulatory roadmaps from the EU, from Washington, there's this really powerful, optimistic consensus out there.
And that consensus is that 2026 is sort of the year, the inflection point where AI innovation finally has to bend the knee to human-centric responsibility, to traceability.
Exactly.
Yeah.
Strict traceability, perfect explainability. All these goals are seen as not just desirable, but achievable.
It's this idea that we can have it all, right? We can have these incredibly powerful general AI systems, but we can still force them to be, I don't know, a compliant, transparent legal entity.
It sounds so reasonable on the surface. Of course we want that.
Of course. But the main source we're unpacking today, this incredibly dense and scholarly paper, AI Accountability Beyond Abstraction by Chandra Nath, it just throws a tactical, deeply analytical wrench right into the middle of that whole idea.
It really does. And Nath's paper isn't just, a philosophical disagreement. It's a scholarly refutation, and it's grounded in very specific technical and strategic constraints.
So it's not just saying this is a bad idea, it's saying this is mathematically and geopolitically impossible.
Precisely. It argues that the current policy push, demanding strict explainability from these models and trying to get global agreement on ethics is, and I'm quoting here, profoundly disconnected from the reality of how machine learning actually works.
And we should probably talk about the source of this critique, because it's critical to establishing its authority. Nath isn't just an ethicist or a lawyer.
No, not at all. The author is a former computer science faculty member, so they understand the nuts and bolts of neural networks. But they also have a military veteran background.
So they get this strategic, geopolitical implications of putting constraints on your technology when you're in a competitive environment.
Exactly. That dual background gives us this unique lens. It's both technical and strategic, and it forces us to look at this neat and tidy solution of perfect accountability and ask, what are the real pragmatic costs?
And this is why this deep dive is so vital for you, the learner. This isn't some soft philosophical what-if debate. This is about the hard, measurable limits of the tech itself.
And the hard, non-negotiable limits of geopolitics. Nate's core argument is that the whole regulatory framework right now suffers from what they call a dangerous abstraction.
A dangerous abstraction. What does that mean exactly?
Well, it's dangerous because policymakers, Nath contends, are treating AI as if it's a single, monolithic thing, like a predictable software program or a car engine that you can audit and control.
Right, but it's not.
Not even close. The reality, as Nath points out in exhaustive detail, is that modern AI is just a really diverse set of probabilistic mathematical techniques. They're constantly adapting, constantly evolving.
So if you try to govern this complex, shifting, probabilistic tool as if it's a simple deterministic machine where every action can be traced back in a straight line,
your policy is doomed from the start. You're essentially governing a ghost.
And this failure, according to the paper, shows up in 3 critical ways. This is basically the roadmap for our deep dive today.
Right. We're going to unpack the 3 main disconnects that Nath identifies between what policymakers want and what is actually possible.
Okay, so we've got the technical impossibility, the legal loophole, and the strategic vulnerability.
Specifically, that's first, what the paper calls technical incoherence, the fundamental impossibility of trying to legislate the black box.
Okay.
Second is the structural failure of liability dumping. So how the corporate frameworks are set up to shield developers from any real accountability.
And
finally, the really big one, strategic asymmetry. The national security risk that we create for ourselves with all this self-imposed regulation in a competitive world.
Okay, let's unpack this. We have to start where the rubber meets the road. The technical foundation. Failure number 1. Trying to impose deterministic law on a probabilistic system.
Right. And to really get this, we had to start with a foundational clash. It's a clash between centuries of Western legal tradition and the absolute cutting edge of computer science.
So our whole legal framework, especially when you're talking about liability, negligence, that sort of thing, it's built on a very specific idea.
It is. It rests entirely on what's called deterministic causality.
Let's define that really clearly. What's the legal causality baseline?
It means linearity and clarity. A court needs to be able to draw a straight, unbroken line from a cause to an effect.
Okay, so give me an example.
Think of a product liability case. A manufacturer designs a faulty brake for a car. That brake fails. That failure causes an accident.
Right. Action A leads to outcome C. You can trace it.
You can trace it perfectly through the engineering specs, the manufacturing process, the maintenance logs. That clear chain of events is what the law is built to do. It identifies that chain, assigns blame, and establishes responsibility. That's the baseline.
And that baseline, that need for a straight line, is utterly incompatible with how sophisticated AI actually works.
Utterly incompatible. And Nath argues this is the critical point that policymakers are just willfully ignoring. Modern deep learning, and especially large language models, LLMs, are fundamentally probabilistic systems.
They're not following a set of rules.
Exactly. They aren't following a step-by-step reasoning path like a traditional, if-then computer program that an engineer wrote out line by line.
So if it's not following a script, how does it operate? Let's get into the mechanics a bit in simple terms.
Okay, so imagine the system is trying to decide the next word in a sentence, or the next action to take. It operates on what are called high-dimensional vectors.
Okay, that sounds complex. Break that down.
Think of a dimension not as physical space like length or width, but as a feature. It could be the color of an object, its context in a sentence, its emotional tone, how often it appeared in the training data. Thousands of things.
So it's looking at a concept from thousands of different angles at once.
Thousands of angles. And the system's decision is the outcome of multiplying and adding millions or even billions of weighted parameters across all those dimensions. It's just this enormous complex calculation that spits out the highest statistical likelihood for what should come next.
So it's not logic, it's a vast statistical prediction. It's basically saying, based on the trillions of data points I've ever seen, this is the most mathematically probable thing to say or do next.
Precisely. And because of that mechanism, the paper makes its most blunt and I think most memorable technical assertion about this legal mismatch. Manetha writes, technically, we cannot subpoena a probability distribution.
Wow. That phrase, it just perfectly encapsulates the chasm, doesn't it?
It does.
You can subpoena a document, an email, a record of a human decision. These are all discrete, deterministic pieces of evidence.
Right.
But you can't walk into a courtroom and demand that this billion-parameter calculation in a neural network somehow converts its abstract mathematical state into human-readable prose that satisfies the legal definition of intent or negligence. It's impossible.
The weights within that neural network are the decision maker, in a sense, but they exist completely outside the causal framework that the law requires.
So let's take a real-world example. An LLM is used in a hospital to help with diagnostics. It recommends a course of treatment that ends up harming a patient. The legal system wants to know why. Why did the model choose that specific recommendation?
And the technical answer is, because that unique sequence of a billion parameters, weighted across dozens of hidden layers, resulted in the highest statistical confidence score for that output.
Which is an answer that is mathematically precise, but legally it's completely meaningless?
It's meaningless. The legal system is looking for a human-like story of cause and effect, of reason, not a statistical summary of how the training data influenced the math.
And this leads us straight into the core dilemma that faces anyone trying to build or regulate these things, this trade-off between performance and interpretability.
Yes. We desperately want AI that is super high-performing, but the policy world is demanding that it also be highly interpretable.
And Nath's work, which cites a lot of existing research, confirms that those two desires are often mutually exclusive. You can't have both.
They're constraints on each other, not complements. Mandating explainability creates a direct and often very costly trade-off with performance. The paper cites some really influential research here, Doshi, Velez, and Kim from 2017, which basically posits that the most capable, the most powerful AI models are almost always the least interpretable.
They become black boxes precisely because their internal complexity is what makes them so good at making predictions.
Right. Their complexity is optimized for accuracy, not for human understanding.
Let's elaborate on that. What does that mean for a developer? So if I'm building, say, a simple decision tree model.
Okay. Yeah.
It's super interpretable. Every node is just an if-then statement that I can trace from top to bottom. But it's also not very smart. It can't handle a lot of complexity.
Correct. It's a glass box, but a weak one.
But if I use a massive transformer model, something like what powers GPT-4, it can handle nuance and complexity infinitely better. But its decision pathways are effectively invisible. I can't trace them.
And the paper highlights that this is the policy implication that regulators have to face. Mandatory explainability could potentially, and this is a quote, cap the intelligence of the system.
You're putting a ceiling on how smart AI can get.
You are. If regulators strictly enforce transparency, they risk forcing organizations to ditch these superior, opaque models, the transformer architectures that are driving all the modern breakthroughs, and instead use demonstrably inferior but interpretable models,
Yeah.
like simpler statistical regressions or those decision trees you mentioned.
So we're being asked to choose. We can have an AI that is profoundly smart but basically mute about its own reasoning, or we can have one that's mediocre but can give you a beautiful, easy-to-read flowchart explaining its simple decision.
That's the choice.
And if we choose the flowchart purely for the sake of legal compliance, we are deliberately hamstringing our own technological capability, and that has huge economic and, as we'll get to later, strategic consequences.
Right. The trade-off is often ignored because it's just convenient to assume that a smart AI can also be perfectly transparent. But the reality is that the very features that make these models so powerful, the immense scale, the abstract multi-layered feature detection, are the very things that obscure their internal logic from us.
Okay, so if the law demands an explanation and the system can't provide a real one, what happens? This gets to Neth's point about post hoc rationalization.
This is where we move from a technical problem to a legal illusion.
Yeah.
To get this, we first need to understand the concept of a legal fiction. A legal fiction is something that the court agrees to accept as fact for the sake of a legal proceeding, even though everyone knows it's not literally true. The classic example is that a corporation is legally treated as a person.
Right. A corporation can't breathe or think, but for legal purposes, it has rights and responsibilities like a person. It's an accepted untruth that makes the legal machinery work.
Exactly. And the explanation that an AI generates is becoming a new kind of legal fiction. When the court or a regulator demands to know why an AI made a certain decision, the AI doesn't genuinely open up the black box and show its work.
So what does it do?
It engages in what the paper calls post hoc rationalization. It generates a plausible-sounding story, a narrative, or a simplified chart after the fact to justify the output it already produced.
So it's using its massive predictive power not to make the decision, but to predict the most likely explanation that a human auditor will find acceptable.
That is exactly right. And the paper really emphasizes the gap here. This generated explanation may not, in fact, likely does not accurately reflect the complex mathematical pathways that the hidden layers of the network actually took.
The real reason remains hidden.
The neural weights that actually drove the decision remain untouched, untraceable, and unexplained. The explanation is just a secondary output that's been optimized for human consumption.
So if the explanation is a fiction, how can any court or any regulator genuinely hold the system accountable? We haven't regulated the mechanism, we've just regulated the story it tells about the mechanism.
And that's Neth's core argument on this point. This regulatory path legislating based on this illusion is not true accountability. It is merely compliance with a legal fiction.
We've satisfied our human need for a narrative, for a story.
Yes, but we haven't gained any actual insight into why the probabilistic system behaved the way it did, or, more importantly, how to prevent a real systemic error from happening again. We've just codified the acceptance of a plausible lie.
Okay, so let's synthesize failure number one. The fundamental architecture of modern AI is just incompatible with the linear, deterministic demands of our legal system.
Right.
Forcing transparency on it creates a crippling trade-off with performance. And when we demand an explanation anyway, what we get is a sophisticated, statistically generated story that serves as a regulatory placeholder, but it isn't the truth.
The technical foundation for real accountability is just. It's rotten, which then leads us to the consequences of building a legal house on that rotten foundation.
So if we accept that the math makes true accountability impossible, the next question is, what kind of legal and corporate structures are being built on top of that impossibility? And that brings us right to the governance paradox, failure number two.
Exactly. If the first failure was in the math, this one is all about the law and really business incentives. Nath argues that even if these models were somehow perfectly transparent, the governance framework we have now is structured to be, quote, toothless. It's designed to shield the most powerful players from any consequences.
And this is where the paper introduces the concept of governance theater.
Yes. It's a really cutting critique. It's a performance for the public, for regulators. You see countless forums, conferences, white papers, all dedicated to these lofty ethical discussions. You get this torrent of pro-responsibility rhetoric and abstract guidelines.
But the paper's point is that these discussions conveniently fail to engage with the structural reality of corporate liability,
Mhm.
of who actually pays.
Precisely. So you keep these beautifully written ethical guidelines focused on big ideas like fairness and do no harm. They're wonderful aspirations, but Nath argues they are toothless because they don't change who pays the actual financial or legal price when a system hurts someone.
They're about what companies ought to do, not what the law compels them to do.
Right, they lack concrete liability mechanisms. Nath points out that a big tech company can tick all the ethical guideline boxes. They can publish a glossy report saying they value human dignity, but if their end-user license agreement, their EULA, is structured to push all the risks onto the customer, then the ethical talk is meaningless.
So accountability only really exists if there's a way to hold the creator liable for negligence that's baked into the model's design or its training data.
And right now, there isn't. Which brings us to the central analogy the paper uses to describe how developers insulate themselves. It's called the gun manufacturer defense.
This is a really potent analogy. Let's break it down.
It's crucial for understanding the whole problem. In many places, traditional gun manufacturers have significant legal protections. They are shielded from liability for the misuse of their product.
The argument being they produce a functional tool, and the liability rests with the person who chose to use it or misuse it.
Exactly. And it sees the major AI labs using a very similar legal structure, just implemented through their EULAs and their API terms of service.
So let's define the roles in this analogy, because that's what defines how the risk gets transferred.
Okay, so the developer, the big company that builds the foundational model, the LLM, like a major tech lab, they are functionally providing the weapon, the model itself.
They train it, they make it powerful, and they license access to it, usually through an API.
Right. Then you have the deployer or the end user. This could be a smaller business, a school district, a hospital system, even a military command. They are responsible for the firing.
The firing being the specific output the model generates in a real-world situation.
And the EULA is the legal firewall between them. It's the mechanism that legally separates the developer from the consequences of that firing. It lets the developer keep all the profit and the innovation credit while washing their hands of any and all consequences when it fails.
And Nath gives this a specific name.
Yes, a liability dumping paradox. The creators of the most powerful and most opaque technology in the world successfully externalize all of their risk onto their downstream users.
And if you read the fine print of these agreements, it's all there.
Oh, it is. The fine print of these ELAs, these terms of service, they almost always contain these incredibly robust indemnification clauses and limited warranties. It basically ensures that if the system makes a bad decision that leads to a lawsuit or financial damage, the end user is the one who's legally and financially on the hook.
It's a huge problem because this shifts the entire burden onto people who have zero visibility into the system's black box.
No.
They don't control the training data, they can't see the architecture, they have no idea what the safety mechanisms are. They are just licensing a probabilistic tool and hoping for the best.
And the paper is very specific about the societal cost of this. Who actually pays the price for this liability dumping? It's not the corporate giants. The risk gets transferred entirely to end users who are often less sophisticated, less well-resourced, and just trying to apply this new tech ethically in really difficult jobs.
Can you give us some of the examples that Nath cited in the source material?
Sure. The list includes school teachers who are trying to use AI tools for, say, curriculum generation. They could be held liable for copyright infringement or biased content produced by the model.
Okay.
Hospitals implementing diagnostic AI. A misdiagnosis leads to a malpractice suit, and the hospital is the target, not the AI developer.
Right.
And significantly, junior military commanders. They're making rapid, high-stakes decisions based on algorithmic recommendations, and they face disciplinary action or career ruin when the probabilistic system makes a mistake.
Let's use a quick scenario just to really cement this for everyone listening. So imagine a regional hospital. They implement a new AI diagnostic model from a huge developer. The EULA says the model's accuracy is best effort, but disclaims all liability for patient outcomes.
A pretty standard clause.
So the model, because of some subtle bias in its training data that no one at the hospital could have known about, consistently fails to diagnose a rare condition in a specific demographic. A patient is harmed. Who gets sued?
The hospital gets sued. The doctor who followed the AI's recommendation gets sued. The API provider, the developer who built the flawed foundation, stands safely behind their corporate shield.
And their defense is just, we provided the tool, the hospital chose how to use it.
The hospital chose to deploy it. Nath argues this model is completely unsustainable. You can't have responsible innovation if you have zero accountability for the core product.
So what's the remedy? What does the paper propose?
Nath is very clear on this. True accountability requires piercing the corporate veil of the API provider.
Piercing the corporate veil, that's a pretty significant legal move. It's usually reserved for cases of fraud or gross negligence. What does that mean in this context?
It implies that regulation can't just target the end user. It has to target the source of the technology. It needs a legal mechanism that can override these standard EULAs, arguing that the developer is a central party in the chain of causality, even if the deployment is handled by someone else.
It's acknowledging the inherent danger and opacity of the foundational model itself.
Right. It means regulation should compel developers to internalize the cost of their product's failures. This could mean things like mandatory high-limit liability insurance that covers this externalized risk, or maybe even a legal escrow, where funds have to be set aside to cover potential societal harms caused by these black box models.
Because just regulating the end user is pointless. The end user is downstream of the risk, not the creator of it.
Exactly. What's fascinating here is this whole structure, this disconnect between innovation and responsibility, it creates this perverse incentive loop.
How so?
The centralized power that creates the foundational model gets all the economic benefits of speed and scale.
Yeah.
But the dispersed, less powerful end users are forced to bear all of the operational risk.
It's a system that rewards opacity and speed over safety and transparency.
It is. I mean, think about it. If you're a developer and you know your EULA shields you from all liability, why would you invest millions of dollars and months of time in slow, resource-intensive interpretability methods? Especially when you know your competitor isn't bothering.
You wouldn't. The incentive is to move fast and dump the risk.
So the governance failure is fundamentally one of misaligned incentives, which our current legal structures are actively encouraging.
Okay, so the big takeaway from failure 2 is that all this high-level talk about ethics is just performance. It's just window dressing. If it doesn't fundamentally address the legal mechanisms that transfer risk away from the creator and onto the vulnerable user.
That's it. Until the liability structure changes, accountability remains a hollow promise that's only ever enforced on the little guy.
And this framework of opacity and speed of dumping liability leads us directly into the third, and I would say highest stakes, failure, the strategic vulnerability.
Absolutely. We started with the technical incompatibility and we moved to the legal loopholes. Now we have to turn to the realm where mistakes aren't just lawsuits, they're threats to national security. Failure number 3, strategic asymmetry.
And this is where Nath really brings their military experience to bear, arguing that this domestic push for AI accountability, especially around explainability and human oversight, poses a direct strategic risk in an age of algorithmic competition.
It does. In the defense world, the constraints we put on our AI are immediately transactional. They directly determine capability, latency, and survivability. And to understand the stakes, we have to introduce a foundational strategic concept, the OODA loop.
Observe, orient, decide, act. The decision-making cycle developed by military strategist John Boyd.
Precisely. The OODA loop represents the speed at which a fighter pilot or a commander or an autonomous system cycles through assessing the environment and then acting on that assessment. In military strategy, the side that can cycle through their OODA loop faster than their adversary gains a decisive and often irreversible advantage.
And the primary value of AI in modern warfare, its whole purpose, is to compress that cycle, to operate faster than a human brain can possibly process.
Right. An AI can observe 1 million data points, orient them, and execute a complex decision almost instantly. It can turn a minutes-long human process into a millisecond-long machine process.
Okay, so with that in mind, now consider the regulatory impulse we've been talking about.
Now consider it. Nath argues that when we impose heavy explainability requirements or mandatory human-in-the-loop HITL mandates, we are inherently introducing latency into that system. We're deliberately injecting cognitive friction into the process to satisfy this legal or ethical desire for traceability.
The paper calls this OODA loop friction.
And friction is the enemy of strategic dominance. If your system has to pause, not just to make a decision, but to generate a plausible post hoc rationalization for that decision, and then it has to send that to a human commander for review and approval.
The entire temporal advantage that the AI provided is just gone. Wiped out.
It's nullified. The time it takes for a human to observe a situation, orient themselves to the data, and consciously decide to authorize an action is just orders of magnitude slower than the machine. That human involvement, while ethically desirable, becomes a massive strategic vulnerability.
But let me challenge that for a second, just to play devil's advocate for the listener. Wouldn't the catastrophic risk of autonomous warfare demand more human in the loop, even if it creates friction? I mean, surely the potential for an uncontrolled accidental escalation or an irreversible error requires a pause button.
And that is the crucial tension. That's the knife's edge that policymakers are on, and it's the heart of Nath's critique. The desire for safety is absolutely paramount, but the reality of the world is competitive.
So what's Nath's response to that?
Nath acknowledges the risk, but stresses the asymmetrical nature of the problem. If your adversary uses a fully autonomous and unaccountable system, one with zero regulatory friction, zero mandatory human review, they will gain a decisive temporal advantage. They will be operating inside your decision cycle.
And operating inside the decision cycle. What that means is that by the time my regulated, ethical, human-reviewed system has observed the threat and is preparing to act.
The unconstrained adversary has already completed their cycle, executed their action, and is already preparing for their next one. You've already lost.
The ethical constraint becomes the mechanism of your own defeat.
It does. And here's where it gets really interesting. Because this is the point where the entire Western conversation about a global harmonization of ethics just evaporates. It disappears the moment you acknowledge that not every major global player is constrained by the same ethical or legal framework.
And he basically dismisses that whole idea, the global harmonization of AI ethics, as a myth in a multipolar world.
It's seen as naive and even dangerous to assume that nations who are engaged in existential strategic competition would voluntarily slow down their technological edge just to adhere to some abstract global norms that were probably proposed by their rivals in the first place.
You have to look at the geopolitical reality.
You do. You have, say, the European Union, which is heavily emphasizing the human-centric approach with the EU AI Act. It's focused on transparency, strict rules for high-risk applications. Meanwhile, authoritarian adversaries are prioritizing state power, speed, and capability above everything else. They see constraints as weaknesses.
And that dynamic sets up this critical concept of strategic asymmetry.
Right. If democratic nations, driven by a genuine and deep-seated desire for ethical use and accountability, bind their military AI with rigid traceability standards that their authoritarian adversaries simply ignore,
They create a colossal and entirely self-imposed vulnerability.
the paper details this as a profound risk. The adversary has no internal ethical or legal compulsion to mandate post hoc rationalization. They have no reason to slow down their OODA loop with human consent. Their systems are allowed to be true black boxes, optimized for one thing and one thing only: lethal speed and effectiveness.
And Knight doesn't pull any punches about how severe the self-imposition of constraints is. They frame it as a form of unilateral disarmament via regulation.
That phrase is so stark because it completely shifts the framing away from ethics and onto existential power. The capability provided by unconstrained algorithmic speed is effectively a weapon.
And by intentionally making our version of that weapon slower, less capable, and traceable in the name of ethics.
We are unilaterally disarming ourselves relative to a potentially unconstrained adversary.
The paper goes on to assert that all this loose talk about universal ethics, if it doesn't explicitly acknowledge and model adversarial noncompliance, is not just intellectually naive.
It's worse. It constitutes a vector for national vulnerability. It means our own domestic debate about accountability has itself become a national security risk factor.
So the technical impossibility we talked about is now meeting strategic necessity. If we solve our domestic accountability problem by imposing friction and slowing things down,
We simultaneously create a massive geopolitical weakness by conceding the temporal advantage to our rivals.
and so democratic nations are forced into this terrible high-stakes choice: do we prioritize domestic safety or strategic dominance?
And the people driving this regulatory debate are often not the ones who understand the operational cost of algorithmic latency. It brings us right back to the core point of the paper. The policy debate has to move from abstract ethics to pragmatic, strategic reality.
The current structure lets us feel good about our ethical constraints without forcing us to adequately model the consequences of those constraints when we're facing an unconstrained actor.
That's right.
Okay, we've spent a good amount of time detailing these three interlocking failures: the technical impossibility of transparency, the legal framework that externalizes risk, and the strategic vulnerability created by our own self-imposed friction. Let's try to pull all of this together.
If we connect this to the bigger picture, The prevailing narrative that AI accountability is just a matter of political will, that we just need to write the right laws. That idea has to be discarded.
It's not that simple.
Not at all. The narrative of 2026, according to Nath, can't be about abstract hope or ethical aspirations. It has to be about confronting these three brutal, non-negotiable realities.
And this is the concise, reframed narrative that we really hope you, the learner, can take away from this deep dive.
So first, the technical reality. We have to accept that deterministic causality cannot be demanded from inherently probabilistic systems. The core architectural features of high-performance AI prevent us from ever truly tracing causality in a legally satisfying way.
Right.
You cannot subpoena a probability distribution.
Second, the legal reality. Accountability is functionally meaningless until the financial and legal liability is properly located. And that means the end-user license agreements have to be fundamentally reformed, and the corporate veil-shielding foundational model developers has to be pierced.
Right. Developers have to be held liable for their product's core outputs. We have to stop this practice of liability dumping onto vulnerable users like hospitals and teachers.
And third, the big one.
The strategic reality. Democratic nations have to consciously avoid regulating themselves into obsolescence in an age of accelerating algorithmic competition. Imposing traceability mandates that our adversaries will simply ignore creates a dangerous strategic asymmetry. It risks national vulnerability through self-imposed OODA-loop friction.
So if the current governance system, which seems to be dominated by legal theorists and abstract ethicists, has created this trifecta of failure, who needs to be in the room to formulate effective, realistic policy?
Neff's final assertion is a powerful challenge to the way these policy committees are currently structured. The paper argues that effective governance requires a fundamental shift in leadership.
Away from the lawyers.
Away from just the lawyers.
Yeah.
It needs practical expertise from the people who actually build and deploy these systems. Advanced computer scientists who understand the math, and operational military strategists who understand the meaning of temporal advantage in a decision cycle.
So the governance discussion shouldn't be led by people whose main expertise is interpreting existing legal statutes in a courtroom. We need people who understand the physics of the black box and what happens when you slow it down.
The paper states it definitively. True governance requires expertise in the field, not just the courtroom.
Which means policy has to be set by people who understand that technical trade-off between performance and interpretability and the strategic cost of latency in a competitive world.
It implies a massive restructuring of how AI policy is made, forcing technical experts and operational leaders to define the constraints, rather than lawyers trying to cram this radically new technology into outdated legal boxes that were designed for deterministic mechanical failures.
It demands realism over idealism.
We need solutions that work with the probabilistic nature of AI and the multipolar nature of the world. And that means acknowledging that a perfect, universally enforceable, human-centric accountability framework for black box models might simply be mathematically impossible and strategically suicidal.
The goal shifts.
The goal shifts from perfect accountability to managed risk.
And that leads us directly to the final provocative thought for you, the learner. So what does this all mean for you?
This whole deep dive into Nath's paper, it really highlights this foundational zero-sum tension at the heart of AI governance. We've seen it across the technical, the legal, and the strategic dimensions.
It's this core trade-off.
It is. If the most capable, cutting-edge AI systems are inherently black boxes, and if the regulatory pressure, which is driven by very genuine desires for ethical safety, forces us to choose transparency over capability, what is the ultimate choice for governance?
If the choice is between making our systems highly explainable, auditable, and thus demonstrably safer for our own domestic use, but at the same time making them strategically slow and ineffective against an unconstrained rival, we face a terrible dilemma.
And that's the provocative thought we want to leave you with. Is the ultimate choice for democratic nations in this new technological era truly between maximizing safety and retaining strategic dominance?
And if it is, which failure are we more willing to tolerate? The internal ethical one or the external strategic one?
It suggests that if we choose to solve the technical and legal problems of accountability by slowing the system down, we are simultaneously choosing to create a strategic vulnerability. It's a profound challenge to the current consensus.
And one that demands immediate critical reflection. Every time you see a new policy proposal come down the pipeline,
You have to ask, what is the cost of this safety measure? Not just in dollars, but in capability.
a profound challenge to the consensus and a necessary reality check on the limits of AI governance. That's it for this deep dive. We hope this exploration gives you the clarity you need to navigate the real limits of AI accountability.